Asynchronous versus synchronous resets. Which is better? You will be asked this question in various different forms in your phone screens or on-site interviews. So let's go through all the characteristics of asynchronous reset and then compare these characteristics in case of synchronous reset and get a full understanding of how each one of these fare. So asynchronous reset is not part of data path, and this you may have learned during your master's digital design course. Second, asynchronous reset doesn't depend on the presence of the clock, meaning you can reset a part of the circuit that has asynchronous reset even in absence of the clock. The effect of asynchronous reset can happen anytime, which means anytime asynchronous reset becomes active, the circuit that's hooked up to it is going to immediately get reset. Asynchronous resets are extremely prone to glitching, so they are never recommended for internally generated resets. There are no requirements on minimum reset pulse width. Since there is no clock associated with asynchronous reset, there are no requirements on minimum reset pulse width. Now we're going to go ahead and compare each of this characteristic and see how synchronous reset is different compared to asynchronous reset. So synchronous reset is obviously part of the data path since it's dependent on the clock and thus the name synchronous reset. Synchronous reset depends on the presence of clock, meaning you cannot reset a circuit which has synchronous reset in absence of a clock. And that's a major distinction between asynchronous reset and synchronous reset. Let me recap this one more time because this is a very important distinction. In case of asynchronous reset, you can reset the circuit even in the absence of a clock, whereas synchronous reset is dependent on the presence of clock for resetting the circuit. Let's move on to the next one. Synchronous reset, the effect of that reset will happen only on the active edge of the clock. Since we said the reset is a part of data path, the reset will take effect only on the active edge of the clock. So if your circuitry that the synchronous reset is hooked up is all active high flip-flops, rising edge flip-flops, then the reset will take effect on the rising edge of the clock. Conversely, if all the flops in your design are falling edge flops, then the reset will take effect on the falling edge of the clock. The synchronous reset is perfectly suited for internally generated resets. The reset pulse width has to be long enough to be sampled on the active edge of the clock. So this is a very important point. Think about it. If your synchronous reset is toggled or is active for just a fraction of the clock period, and that happens to be not during the active edge of the clock, then the circuit is never going to catch that reset pulse. That's why there is always this inherent constraint on the synchronous reset that the reset pulse has to be at least a few times of the clock period of the clock that is getting used.